When a capacitor is connected to a power source, it stores energy that can be released when the capacitor is unplugged. We prove this through the following experiment. A capacitor is charged via a DC voltage source. Then, the capacitor is disconnected from the voltage source and connected to an LED. We see how this LED lights up for a certain time. But how so? In its most basic form, a capacitor consists of two parallel conducting plates, which are electrically separated from each other either by air or by an insulator. We can also name this insulator a dielectric. The positive charges accumulate on one plate, and the negative charges accumulate on the other plate. This separation of charges creates an electric potential difference between the plates. The following applies here. The higher the voltage applied to the capacitor and the bigger the capacitor, and let's name it correctly, capacitance, the more charges can find a place on a plate. Regarding the capacitance of a parallel plate capacitor, the bigger the plate area, the more charges can find their place. The distance between the plates also has an influence. The smaller the distance between the plates, the more the charges on the opposite plate attract each other, and the more space there is for the charges on the plates. Finally, we increase the capacitance with the dielectric, which is nothing more than an insulator between the plates. Electric dipoles of the dielectric align themselves with the charges of the capacitor and neutralize them. Thus, more charges find places on the plates of the capacitor. The factor by which the dielectric material increases the capacitance of the capacitor is known as the dielectric constant. The generalized equation for the capacitance of a parallel plate capacitor is given as shown. The charging and discharging curves of capacitors are exponential in nature. At the first moment, the capacitor is connected to a voltage. The initial current is high because the plates of the capacitor are empty of charge. The charging current asymptotically approaches zero as the capacitor becomes charged up to the voltage source. The rate of charging is typically described in terms of a time constant RC. Let's switch to get the LED light, and we see that the discharge curve is also exponential. The difference between a battery and a capacitor is that batteries store energy through electrochemical reactions, while capacitors simply store charge. Perhaps this can solve the energy problems of electric cars in the future. You can find more information about capacitors and more calculation examples on our website. Stay tuned and never miss a new video.